So let's go over how to write an acid-base reaction. Let's look at nitric acid reacting with potassium hydroxide. Okay, how would we figure out what the products are going to be? Well, what we want to do is we want to remember that our acid is really H plus and nitrate, and our base is going to be K plus and OH minus. Now, what we're going to do is we're going to switch our ions, and maybe the best way to do it is to write our base underneath here and just connect these two. H plus and OH minus, we know, are going to form water. And then what's left is our K plus and our nitrate. And since these have charges that cancel one another out, it's a 1-to-1 ratio of cation to anion. And since potassium and nitrates are always soluble, the state that this product is going to be in is going to be AQ. So we see here this double displacement, the switching of our cation and our anions to form a new product. And we want to remember that our acids and our bases are going to form water. 1H plus is going to react with 1 hydroxide to form water and a salt, which is going to be an ionic compound. Now let's look in more detail at this strong electrolyte concept. Strong electrolytes are 3 types of chemicals. They're either soluble ionic compounds, strong acids, and strong bases. And what strong electrolytes do is they completely dissociate into ions when they're dissolved in water. And I'll abbreviate that by AQ, completely dissolved, completely dissociate into ions when they dissolve in water. Now, we've already looked in detail at soluble ionic, and all the strong bases are actually ionic compounds because they all contain metals and the polyatomic ion hydroxide. So strong bases and soluble ionic compounds are going to be basically the same, and I've already went over soluble ionic compounds. Let's take a look at strong acids because they're a little bit different. Acids in the molecular state. Let's look at hydrochloric acid. That will be our beginning one. If we look at hydrochloric acid, hydrochloric acid actually exists in the gas state. And if we look at the 2 elements that compose it, hydrogen and chlorine, this is a molecular compound. It's not ionic, it's molecular. And when we get to later chapters, we'll see that we can draw this as a molecule, and there are 2 electrons being shared between hydrogen and chlorine that form what's known as a molecular or covalent bond. However, when hydrochloric acid is dissolved in water, what it does is it acts like an ion, and the H separates from the chlorine, and the 2 electrons that were being shared now go to the chlorine atom. So we have a chloride ion and H plus. Now let's look at hydrogen. Hydrogen has 1 proton and 1 electron if we look at a hydrogen atom. If we look at H plus, we've lost an electron. So all it is a proton. So many times when we refer to H plus, we call it a proton because really that's all it is. It has no electron. And this is one of the reasons that acids are so reactive, because this H plus actually wants an electron. Now it's stabilized by the water molecules. And this is why it separates. It's very stabilized by the water molecules. But if it comes in contact with other chemicals that have electrons that are readily given up, then it will react with it. So all strong acids are strong electrolytes, meaning that they completely dissociate. And the cation that dissociates when an acid is dissolved is always going to be the proton, the H+. So if we looked at HBr, I'll get a new piece of paper here. If we looked at HBr, that's a strong acid. And if we dissolve that in water, it is going to completely dissociate into H+ and bromide. So those are strong electrolytes. Now let's look, let me do the polyatomic just to be completely clear. Again, we're going to dissociate the H+ and the nitrate. Now there's going to be no molecular acid in solution. The H and the Br are not going to stay together once they're dissolved. Now if they're all by themselves, not in water, they're going to be molecules. But once they're dissolved in water, then they separate into ions. And so all strong acids are strong electrolytes. Okay, now let's look at weak acids. Weak acids are weak electrolytes. And what that means is they only partially dissociate. We only get a small amount of ions when they dissolve. So here is an acid that is a weak acid. How do we know it's a weak acid? Because it's not a strong acid. And this is a binary acid. This would be hydrofluoric acid. And when it dissolves, we get the proton and the fluoride anion. But we also have the molecule or the molecular acid in solution as well. In fact, most of this is what is dissolved, and only a tiny, tiny bit of this compared to the molecular acid is dissociated. So for all weak acids, there is going to be the molecular acid dissolved and just a small, small amount of the ions formed. Now this is a weak acid because it's not a strong acid. This would be nitrous acid. And we use these double arrows to explain that we have all three species in solution. As soon as the H+ and the F- find each other, they go back to the HF. And in weak acids, we have most of the molecular acid in solution and just a tiny, tiny bit of the ions that are dissolved. Now, there's only one weak base. There's only one weak base, and that is going to be ammonia. And I'll just put it here for completion. Our one weak base that we're going to know is ammonia, but I'll describe that more in chapter 14. And let's just quickly go over all solutes. Solutes are either going to be non-electrolytes, which are typically molecular compounds such as sugar. And then we could also have electrolytes, which means ions are formed when they dissolve. An electrolyte is either going to be strong, such as a strong acid, a strong base, or a soluble ionic compound. Those are all strong electrolytes. They completely dissociate into ions. And then we could have weak electrolytes, which are going to be weak acids, which is any acid that's not strong, and then a weak base. Our only weak base is going to be ammonia. And these only form a small amount of ions when they dissolve.